Good morning, boys and girls, and welcome to the mess hall here at Dr. Jet Laboratories. I have finished the jet juice. I will not insult you with the jet juice container in front of the camera lens. Working on the design of the cat. Well, gave a lot of thought to skinning it. At first, I thought of the economic benefits of just using one kind of wood, but in reality, I've got to go with 32nd ply on the skins. I will make the ride pads and the outer sides out of 16th inch ply because one, you want the ride pads sturdy, and this is the part that gets all the impacts, is here on the side. That's where you get your impact loads, is on the sides. And because I'm laying everything out in the sponsons, still got to give batteries a thought. Because I'm laying everything out in the sponson, I'm not really too concerned with what's happening here in the center section. It's looking pretty thin. I mean, this is just slightly over an inch here, so that's less than an inch. So this is pretty tight in here, but I think I can get a speed control in there if I had to. My plan is to just have hatches here on the sponsons, and we'll talk about that in a bit. So once I kind of have this firmed up, and I'm basing it on a motor of this diameter here. What did I say this was? 1.16 inches. So I'm kind of laying it out on there, and I'm looking at where this shaft's going to go. And so I'll have to project an isometric there to get the right angle to dangle on the motor plates. But once I get the sponson cross section done, I can lay out the cat. And so here's a couple of things I'm going to do for simplicity. One, this inner rail right here, this inner spray rail, I'm not going to bother curving it or doing anything like that. I'm going to run it just right up to the bow straight. That way you just have a flat skin on it, easy, boom, there it is, glued in place, you're done. And it makes the bow look a little wider. So that's a little design trade-off there. Again, straight lines are easier to work than curves. I want to keep the curves to a minimum, and really they're just here and here. So that's the plan there. I got to thinking about the shape of the center section, and I may want to put a top on it. So I kind of want the center section to allow for a top. And because I'm not putting batteries or anything here in this center section, it doesn't have to be that deep. So I can keep it fairly shallow here. Yeah, now I know this big open mouth here tends to pack air, but it's tightest here from the balance point aft. So if anything, it'll have more pressure here. It'll want to fly the boat, lift the transom, rather than the bow. If I'm wrong with that, and it's just packing such a volume of air here that it blows it off, I can always put an air dam up here near the front. And so the prototype testing will tell me whether or not this shape works. And that'll be so easy to change in production modeling, just, moving a couple of lines. So that's my thinking there. I looked at putting a piece of 1-inch foam on top of this and see if the proportions still looked right. And that still looks, right. So this little flat slab I'm making here would look better with some foam on top of it if you want to do that. And what you could do is, because I'm designing this thing, that this sponson, the separate center section, and this sponson will all have carbon fiber rods holding everything in alignment and position as you glue it together. Before you glue it together and you're making your foam top for the sponsons, you could take little short pieces of carbon fiber rod and put the two sponsons up against each other. And if you wanted, you could even create a template of the shape of the deck of your sponson. Glue some foam on and sand it to that shape. And then the same thing with the center section, glue foam on, and sand it to the shape. Now, here's the thing. And I think this will work. I'm going to have some hatches in here, just openings in this 30-second ply, and it'll have a little 30-second ply lip on the inside to hold the ply lid in place. But that ply lid will have to be glued to a piece of foam that'll come off. So there'll have to be some forethought in gluing this thing up. So you may want to have separate pieces where the hatches are, so that the entire little block of foam and the hatch will come off as one piece, and then you can tape it up when you're running, and it'll tape up as one piece. So you'll need to think about that. I'll work those details out when we get there. The next thing I have to do is establish the angle of dangle of the motor. So I'll need to put a coupler on here. This is the motor I'm planning on recommending. These things are ubiquitous. They're cheap. With the prop sizes that are available and counter rotating, this motor's probably really good for 2S. If you run it on 3S, it'll run for a while. And then, that magic smoke. Although with this fan, it does a pretty good job of cooling it. So your mileage may vary. I've seen these motors blow up under too much, but they were probably under too much when they blew up. I'm going to leave the hull design open for the bigger can 450 motors, just because this motor's 3,800 kV and will swing a whole lot bigger prop than this one would. This one would probably swing 32 millimeter props, 3-bladed, all day long. So just some thinking there. People asked what rudder. This, the ubiquitous, again, cheap Chinese rudder. Everybody's got one. It works. It's the right size. T-Lar. Look, see, T-Lar. That looks about right. So, see, okay, we're in the right neighborhood. Oh, that's 30 millimeter prop right there. So it all looks good. Okay, boys and girls, until next time, jet out.